Okay, welcome everybody. I'm glad you made it. A bunch of intrepid Arctic explorers made it to class today in spite of this weather. It's still snowing out there. I just can't believe it. Here we are in March. But soon enough it'll be hot and we'll wish the snow will be a distant dream. Let's start by taking a look at the announcement here. The homework number 9, that's due on Monday. Anybody started on that assignment already? Good, because I don't want to say it's a long one, but there's some big ideas wrapped into that assignment. The incremental analysis that we did in class on Wednesday, that's kind of tricky. And so since you've only done it one time, it's going to take a little bit of extra effort to figure out on the homework assignment. Same thing with today's in-class exercise. We're going to do another incremental analysis, and it's a really detailed spreadsheet procedure that, it's not brain surgery, but it's more than just discounting a cash flow diagram to the present. So there's some more complicated ideas in this assignment. So it's an important one. Don't wait until Sunday at 11:59 p.m. It won't go well if you put this off to the very last minute. Okay, so that's on the schedule for Monday. Also, in the back of your mind, you should always be thinking about the project and what kind of progress you can make on that. Now, today we're going to be talking about a new kind of incremental analysis. What we did last time was we did an incremental analysis between alternatives where I think in both cases the useful lives were the same. Remember that one of the advantages of annual worth analysis is it can be used for alternatives where they have a different useful life, a different number of years, but you don't have to manually execute the repeatability assumption. So it's kind of an attractive alternative when you're comparing two things that may last a different amount of time. And by the way, how would you define the word increment? What does increment mean? Difference, right. So we're analyzing the difference between two alternatives. All right, so this rate of return analysis, where we're doing it specifically with annual worth, we do it because sometimes alternatives present themselves in a way where you're going to be paying for them on an annual basis. It's becoming increasingly common for things to be offered on a subscription model. One illustration of that is Adobe. I think I've mentioned it before. Adobe and their video editing and photo editing software now is on a monthly subscription. A lot of businesses realize that electronics need to be refreshed regularly. And so your phone, your laptop, that sort of equipment is becoming outdated so quickly that maybe it makes more sense for them to just lease on a short-term basis that equipment rather than buying it outright and holding it for 5 years, and by the end of that 5 years it's barely usable. So maybe, for instance, if you're going to be analyzing two different notebook computer options, an HP notebook computer versus a Lenovo notebook computer. So sometimes because of either the different useful lives or how it's going to be paid for, it's preferred to compare these alternatives on their annual worth, meaning the difference between their annual costs and the annual revenues that can be generated and so on. And so when that's the case, if you want to find the rate of return on the difference, because remember they're not going to have the same price. That would be very unusual for two alternatives to have both the perfectly same number of years of useful life and the same cost. And so generally these options will have extra cost, and so then the question is it worth paying extra for the Lenovo? Maybe the Lenovo has 16 gigs of RAM compared to only 8 for the HP, and maybe the Lenovo has a faster processor compared to the HP, and so maybe it's the more expensive alternative, but maybe it will allow the employees to be slightly more productive. If it reduces the delay between when invoices are shown and when they can be executed, if you're in charge of a big IT system for a company, in theory, the faster, more expensive computer should enable better productivity. And so let's say that we've got some data on that, and what we want to know is it worth spending the extra money? You know, perhaps the Lenovo costs an extra $400, and so what we're going to be doing is an analysis that answers the question, what is the rate of return on the extra amount? Do you remember what's the decision criteria that we applied in the in-class exercise on Wednesday, where we were comparing the Hitachi, the Volvo, Atlas, you know, different types of trucks? How did we know whether to say yes versus no when we were comparing two options together? What was the decision criteria? What is it? If they were above the MAR. You're halfway right. What's they?
First it was the IRR, and then it was the...
So the first thing we did was the IRR. He's right. By the way, why did we do that first analysis on every alternative? Why did we calculate the IRR? Okay, it's an initial screening just to see if we can reject outright anything that is not suitable. So in that first iteration, we were looking to see, are any of the alternatives yielding less than the MAR? And so if any of them were, then we just threw them out and we didn't even bother with the incremental analysis. So now let's say when we were comparing two options together, we start with the cheapest one, and now we're comparing it to the next alternative, the next most expensive alternative. So the decision criteria. How did we know whether to say yes to that more expensive alternative or no to the more expensive alternative?
The IRR on that increment was greater than MAR.
Exactly right. So you calculate the increment, so that means what's the difference in cost and what's the difference in revenue between the two options. And if the internal rate of return on the difference is greater than the MAR, then you accept the more expensive option. I wrote it on the whiteboard last time, so I won't take the time to do that again. I just bring it up as a refresher that we had a decision criteria. It was how we know whether to say yes or no to the more expensive option. Here, we're going to do the same thing. And what we're going to do is we're going to try and solve for an interest rate that's unknown. We're not going to just be able to use the IRR method, though. We're going to have to do something a little bit more involved to find what is the rate of return on the more expensive alternative. But when we find the rate of return, what we're going to be trying to determine is the rate of return on the more expensive alternative greater than the MAR? So we're always comparing to the MAR. And here's the rule, is you keep saying yes to alternatives as long as that added cost, the rate of return on the added cost is greater than the minimum. Because anytime you can make 11% interest and only pay 10% on the money that you borrowed to get that interest, you should keep spending each additional dollar that yields more profit than cost, because you want to maximize profit. All right, so we're going to go through the process today with an analysis of two different front-end loaders, little ones like this. We've got a cat and a bobcat. Is that the same company? I guess, I don't know. It doesn't matter. These are all fictional numbers anyway. But the alternative here is that option A has some known initial cost. We have an annual operating expense for option A. The lifespan lasts for 10 years, and the salvage value is nothing. Option B is more expensive, and it doesn't last as long. So it's not looking good for option B. The one thing it has going for it is the fact that the annual operating costs are lower. So what we're going to want to do here is, on an annual worth basis, try and find out what's the rate of return for the more expensive alternative. So we're going to be comparing these two options and finding out, is option B worthwhile? And here is the template that we're going to use to solve it. So this is another one where you're going to be using Microsoft Excel. If you don't have Excel with you today, I'd really encourage you to scoot up next to somebody who does, because it's important to kind of work through the logic of this. I've given some pretty detailed step-by-step instructions. The first thing to do, though, is just set up your spreadsheet so it looks like this template. And it's an iterative process where you're going to have to make a guess on what's the rate of return of the difference between the two. So these two alternatives have different useful lives, and what we're trying to figure out is, should we choose option A or choose option B? So I'm going to pause for a moment. You've got these step-by-step instructions, A, B, C, D, and I tell you which functions to use to find each one of them, but there are these blank cells here. What I'm calling cell X is where you're annualizing the initial cost. Cell Y is annualized already. It's given the annual cost, but you're going to have to annualize the salvage value, if there is one, and then find the total annual cost for each. Now, we don't know anything about revenue, and that's okay, because we can still do an incremental analysis on the difference between the options, because one of them is more costly in the present value, but less costly on an annual basis. So this procedure is going to be able to tell you, once you keep changing the guess interest rate, what's the rate of return on the more expensive option. All right, so the given information that we have is on a one-time basis for the initial cost and the salvage value. And we need to annualize it, so it's the Pmt function. We want to refer to the interest rate, and I'm just going to anchor that reference so I can copy it over from the A column to the option B column. And we have to do the minus of the present value, because if we don't, then it's going to flip the sign, as Excel is prone to do. And then I'm just going to change the formatting because that red font just drives me nuts. Currency. All right. So I start off with just some guess value of the interest rate and find the annual equivalent of both of these options. And then I have to do the same thing with the salvage value, the payment function. And I've got this based on the guess interest rate and N. And the salvage value, though, isn't a present value. The salvage is at the end of the life. And so I skip over the present value and I click on this salvage value number in the field of future value. Okay, so it makes sense that it's 0 for that one, but for this one, it's some positive amount. So what that means is you can take the $2,000 as one lump sum at the end of 5 years, or if your interest rate is 1%, then that's equivalent to annual payments of $392. So, I mean, that seems like within the realm of possibility. It's, you know, if we just want to do a check of reasonableness, it does hold out. So now all three of these costs have been annualized: the operating costs, the salvage, and the initial acquisition. And we want to find the total of the three. So X plus item Y plus item Z, all three costs together. And then the difference between the two, it doesn't matter if I do this minus that or that minus this, because really the whole reason I'm doing this difference field is just so that when I use GoalSeek, GoalSeek will have something as a target. Like, I don't know exactly what the amount is going to be, but I know that the two amounts should be equal at whatever this interest rate is that I'm solving for. In class on Wednesday, I showed you a graph that showed the crossover point, that the rate of return is the crossover point where things are in equilibrium. So what we're finding, the internal rate of return on the increment between these two options is the rate of return where they both have the same costs. Okay, so the difference is just going to be now one minus the other, doesn't matter which. And I can play around with it manually, you know, if I can't find GoalSeek, or if you're using a different spreadsheet software that doesn't have it. So, you know, let's see, does 2% get me closer? Yeah, it's getting closer. 3% is even a little better. 4%, but then I start to lose interest in this manual iteration, and I can do it with GoalSeek instead. So that's in Data, What If Analysis, GoalSeek, and I want the difference to be 0 by changing this interest rate. And after just a few moments, what it settles on is 12.64%, 12.65%. Anybody else get that same amount? All right, so it's kind of hard at first to interpret, like, what just happened. Like, you've just got some numbers in a spreadsheet, and it's pretty abstract at this point. So the in-class exercise is set up. It's asking some questions here at the bottom. You must choose option A or option B. If your company's MAR is 9%, which is best? So does anybody think they know the answer to that? Like, is alternative A better or is alternative B better if the MAR is 9%? When what we've learned is, according to this analysis, the rate of return, this 12%, what that represents, let's just label it. This is the rate of return on the difference between the two alternatives. So one of them is more expensive. Option B is more expensive. It costs more money. The rate of return on the difference between the two is 12.65%. So let's assume that you're borrowing the money, and it's going to cost you 9% to borrow the money. Should you take out a loan where you have to pay 9% interest if you can earn 12.65% on the money that you're borrowing? Absolutely. You definitely want to make that investment. So the conclusion here is, let's see, decision. We should select option B, since the incremental internal rate of return is greater than the MAR of 9%. So we did the incremental internal rate of return on an annual worth basis. We can get the same answer if we do it the same way that we did in class on Wednesday. And since we've got some time, let's do a check of that. Could you set this up as just a normal A versus B incremental analysis? Let's revisit how that looked last time. What we had last time, I'll leave this up for just a moment in case you need to copy down the decision. Option B is better, according to this analysis. Okay, let's just do an ordinary incremental analysis. This, like if I'm labeling the sheets, this is incremental annual worth analysis. That's what we just did here. On this one, it's just going to be incremental rate of return analysis. All right. So the way that we do this one is we have year, and then we listed option A. We had option B, and then we'll compare B versus A. Years down through 10. So create, based on the data that I've given you in the handout, create a cash flow table that shows for option A the initial purchase and the annual costs. Option B is going to be a little more tricky because we have to buy the item twice. Remember, for us to compare the two alternatives according to this approach, we'd have to use the LCM, least common multiple. So option B is 13,000, and we're repeating that twice. And there's also going to be the salvage in year 5. So let's make a cash flow table of both options. That's what option A looks like. I'm going to pause for a moment because I want to see if you can figure out what the cash flow sequence should look like for option B. Because, you know, we're having to repeat option B. So let me just paste that in. That's too big. Okay, so for option B, we buy it in year 0 for 13,000, and then we pay 1,600 for the operating expenses. But in year 5, something else is also happening. We have those operating expenses, and we have to buy it again, so 13,000, and then we get the salvage value from selling it. And so what was the salvage amount? 2,000? Okay, so those three things together mean that the net outflow in year 5 is 12,600. And then in year 10, we've got the operating expenses and the salvage value, but we don't buy it another time. So that's what our two cash flow tables should look like. And then now the increment is going to be the difference between the two. The more expensive option minus the lesser of the two costs. We find that. So here is our increment, and now we're going to calculate the IRR on the increment. Now I had a good question as I was walking around. Somebody was wondering, should we do the initial screening? You know, like on Wednesday we started off by just double checking that both alternatives, you know, are they acceptable to begin with? We're not able to do that initial screening on these two options because all of these are outflows, well, with one exception. You can only calculate the internal rate of return when you have revenues. So we can calculate the IRR on the difference, but we can't do the initial screening because we don't have revenues. So let's do the IRR function on the increment. This is just a double check. If we did everything right on the first spreadsheet, then the interest rate we found there should match the interest rate it gives us this way. 13%, and if I have it show more precision, it's that same 12.65%. So again, let's put in the interpretation. Let's not just assume that whoever's looking at this is going to know. Since the incremental IRR is greater than the MAR of 9%, then that means we should select the more expensive alternative. In other words, the added cost is justified. Option B is more expensive, but believe it or not, it's worth it. I didn't think at first glance it was going to be worth it because, you know, it costs so much more and it only lasts for 5 years. But I guess that's why we run the numbers rather than just guess. You know, what it shows is that the rate of return of those savings, you're saving $1,900 each year, and it's worth spending an extra $5,000 if you can save $1,900 1, 2, 3, 4 times. I mean, in retrospect, it's obvious, right? So this is fresh in your mind now. It's never going to be easier to work on the homework assignment than right now. When you just did it, you've got a working prototype on your spreadsheet, so you can adapt that working prototype to the homework assignment. Hopefully that should be the case for all of the problems on there, that you've got, like through the in-class exercises, some sort of a template you can use to understand the questions that are being asked. Sometimes the interpretation is a little tricky, but that's all the time we have for today. Let's take a quick look at the announcement, just that the assignment is due on Monday. I'd be glad to answer any questions that you might have for me over the weekend. Remember that it speeds up the rate that I can answer if you take a picture of the question, because sometimes I'll either be at Captain America playing with my phone, or I'll be out on the trail. I won't take my book with me wherever I'm going, but if you take a picture of the question, then I may be able to answer you when otherwise that'd be tricky. Oh, it's Captain Marvel, right? Not Captain America? That's what's coming out? Yeah. You can tell I'm really excited to go to the movies this weekend.